Our brains are wired to expect boundaries. When we map an ocean, we look for a shoreline. When we study the atmosphere, we look for the altitude where the air thins into nothing. It is natural to project that same geographic logic onto the cosmos. We intuitively assume that if we could fly a ship continuously in one direction, past the farthest stars and galaxies, we would eventually run out of space. We'd hit a solid wall, or perhaps drift into a sudden, absolute void. That there is no physical barrier in space. There is no glowing line waiting in the dark to mark the end of the universe. Yet cosmologists insist there is a strict edge to the observable universe. If there is no physical barrier blocking our path, what exactly is drawing this line across the cosmos? The answer requires us to abandon our normal understanding of geography. The edge of the cosmos is not a destination you can travel to. It is an absolute limit on information, a boundary that defines the reach of our possible knowledge. Out in deep space, the limit of our vision is dictated by two factors: the speed of light and the 13.8 billion year age of the universe. Imagine standing in a dense fog. You can only see a few feet in front of you. The landscape continues beyond that gray mist, but the light from distant objects hasn't reached your eyes yet. This diagram illustrates that concept at a cosmic scale. Earth sits at the center of an expanding sphere, representing the absolute maximum distance light has managed to travel. But someone in a distant galaxy exists in their own unique bubble of visibility. What we call the universe is merely a localized snapshot. It is a view defined entirely by our specific coordinates in space and the specific moment in time we happen to be looking. Because light takes time to cross these distances, looking out into space is functionally identical to looking backward in time. When you look at a galaxy a billion light-years away, you are seeing the light it emitted exactly a billion years in the past. If we push that regression to its absolute limit, we find ourselves looking at the cosmos as it was 13.8 billion years ago, when the universe was only 380,000 years old. At that moment, the universe was an opaque, churning plasma of superheated particles. Space was so dense that light was trapped, unable to travel freely. This is the true boundary of the observable universe. We are blocked not by a wall of stone, but by the era before light was free to move. But the universe is not a static room. The fabric of space itself is stretching, pushing galaxies away from one another. This expansion is accelerating. The distance between objects is growing faster every second. As the expansion stretches the grid of space, it creates a harsh mathematical consequence. There are distant regions receding from Earth at speeds greater than the speed of light. These galaxies aren't breaking the laws of physics. They aren't moving through space faster than light. Instead, the space between us is swelling so fast that their light can never close the gap. This turns the edge of the universe into a moving horizon. As space stretches, it permanently swallows distant cosmic structures, carrying them past the boundary where we can ever hope to see them. The universe is actively locking away parts of reality, rendering them fundamentally unknowable for eternity. This leads to a final question. What exists immediately beyond our horizon? The laws of physics suggest the space out there is identical to our own, filled with the same stars and galaxies we see nearby. This creates a tension between existence and observation. A massive portion of reality continues past our horizon, yet we are physically banned from ever testing, observing, or interacting with it. The horizon acts as a mirror for our own limitations. It proves that regardless of our future technology, there is an inescapable ceiling to empirical knowledge. But standing at this edge should inspire awe. Within this finite, fading bubble of visibility, we have managed to decode the mechanics of the entire cosmos. We are a tiny part of the universe that has learned to see the boundaries of its own cage.